In this video, we're going to look at evaluating functions from a graph, the domain and range of functions, and intervals where a function is increasing or decreasing, all from a graph. In this graph here, we have a function, and remember, a function passes the vertical line test, so I can draw a vertical line anywhere through the graph, and it will only touch one point, and that's what makes this a function. So I want to talk a little bit about function notation first, because it's different than what you've seen when we had things in slope-intercept form and other equations like that. So when we have a function, we have f of x equals, and then our function here. And we can think about f of x as the y value, and let's say this was a linear function, then we would have 3x plus 1. In function notation, we would just write that f of x equals 3x plus 1. So function notation is just giving us the equation, but letting us know that it is in fact a function. So here, when they're asking us to find f of 1, what they're saying here is that x equals 1, and we want to know what is the y value when x is 1. So we'll go over to our graph where x is 1, which is right here, and we want to find the corresponding y value, which is 0. So f of 1 is equal to 0. That means when x is 1, y is equal to 0. The next one is asking us for f of 5. So we'll go over to where x is 5, which is right here. And then we want to find the corresponding y value for that, which happens to be 3. So when x is 5, y is equal to 3. Then we'll look at f of 6. So here at 6 again, we can see that the corresponding y value is 0 there. So what you want to do is you want to find your x value on the graph and then trace over to the corresponding y value when you're given f of a number. Over here, though, we're given f of x equals 1, and we want to know what x is equal to. So this is saying kind of the opposite. Y equals 1, so what is x? So this time, we're going to go over to where y is 1, and we're going to trace the graph over. And here we have to be careful to trace all the way, because you can see when I trace at 1, I intersect the graph in 3 different places, which means I'm going to have 3 different x values. And so for these, we're just going to kind of estimate. So the corresponding x value here, we would say is, about 1.5, so 1.5. If we go over to the next point, we're right about here, which is more than halfway between 5 and 6, so we might say, 5.8. And then here, we're past 8, but not quite halfway, so we might say 8.4. So when y is 1, we have 3 different values there. Now they're saying f of x equals 0. So when y is 0, what does x equal? So here we're looking along the x-axis here. And so again, you can see we intersect in 1, 2, 3 different places. So when y is 0, this x value is 1. When y is 0, this x value here is 6. And then this x value here is 8. Then finally, we'll look at where f of x is 2. So when y is 2, what is x? So tracing over here, we can see again we're going to intersect in about 3 places. First one is here. It's a little bit past 4, so we might say 4.1. Second place right here looks like it's about halfway between 5 and 6, so 5.5. And then here we're past 8, closer to 9, so we might say 8.8 or 8.7 for that one. Again, if they're not exactly on an axis, it's an estimate, and so you just need to be close. The next concept we're going to talk about is domain and range. So remember, domain is all of the x values that the function will reach, and the range is all of the y values that the function will reach. So when we're looking at the x values, we're looking at left and right on the graph. And we're seeing if there's any restriction. So this graph is going to continue indefinitely in each direction. So it's going to keep going down and over, and it's going to keep going up and over a little more. So we can assume that eventually it's going to touch all x values on either side. So our domain for this one, if it's all values, we're going to have negative infinity to infinity. Now for range, we're looking at the up and down values. So again, because this is continuing indefinitely towards negative infinity and indefinitely towards infinity here, I'm eventually going to touch all y values on my graph. So this will also be negative infinity to infinity for this function. Let's look at a different function in terms of domain and range. So again, with x values, these arrows mean we're going to keep going forever and ever, so eventually we'll touch all x values here. So our domain for this one is still negative infinity to infinity in interval notation like we did before. But now for the range, these arrows tell me I'm only going up over here and I'm only going up over here, which means this graph is never going to turn back around and go down and get any of these other x value or y values. So when we're looking at the range, again, we're looking at those y values, and we can see that the lowest y value our graph reaches is at a y value of -2. There's nothing below -2 here. Everything on the graph is above there, and because those arrows go up, it means I'm never turning around and coming back down below that x-axis or even below -2. So my smallest value, remember, goes first, and because I have a value at -2, I have to use that bracket. And then this is going to continue indefinitely up towards infinity. So my range is from -2 to infinity. Now we're going to look at intervals where the function is increasing or decreasing. So the important thing to remember here is that we're always reading a graph from left to right, just like we read a book. So I want to look for where the function is going up for my intervals where it's increasing from left to right, and where it's decreasing, my function should be going down. So let's look at increasing first. If I trace along my graph, I'm going up, going up, going up until I get right about here to 2, and then suddenly you'll notice that my graph starts going down, going down, going down. So my first interval of increasing here, again, this is continuing down indefinitely, so this is going to be from negative infinity, and then I got to, and we're looking at x values here, I got to 2 before I started decreasing, so that's from negative infinity to 2. So tracing along the graph some more, we said we were going down here, now we're going back up. So if I'm looking at this interval right here where I'm going up, it started at 3, this is 3 right here, and it stopped at 5. So I have another interval that's increasing from 3 to 5. Then I'm going back down again here, going down, going down, going down, all the way to here when I start going back up. So I start at, this is at 7 right here. Now I'm increasing again, I'm going up, and now I'm going up towards infinity. So it started at 7 and it goes up towards infinity. So then all those other intervals, this one right here and this one right here, those are all intervals where I'm decreasing. So this first interval I started decreasing at 2 and I stopped decreasing at 3. So that goes from 2 to 3. And then my next interval started at 5 and it ended at 7. Now notice I'm using parentheses for all of these, and that's because at those points I can't be both increasing and decreasing. So I can't use a bracket there to say I'm still increasing at 5, because that's the point where it changed from increasing to decreasing. So on this graph I have 3 intervals where I'm increasing, and I have 2 intervals where my graph is decreasing.